Hi, Emma. It was nice working with you yesterday. I know I've seen you around school, but we've never formally met, so it's nice to meet you formally. I think today we'll just kind of go through the notes for the material that you worked on yesterday in class. So some of it is stuff that you'll feel like you already know or we already talked about, but it's nice to get it down on paper, especially when you start to continue to learn more and more stuff. That way you kind of have things organized. And so I gave you 2 packets yesterday with the book. One that's the notes, and we're just going to go through 2-1. For each type of graph, this first section of graph, these are all what we call categorical graphs. Categorical graphs are called that because they're based on categories that we use to distinguish what were like a separation in the data. And so categorical graphs are bar graphs, both types. Like it can be, you can have the back-to-back or side-by-side. Maybe that's a better way to call it, side-by-side bar graph. You can have a stacked bar graph where you stack 2 different sets of information on top of each other. You can have that Pareto or Pareto. Again, that's a term I really haven't heard, but that's the one that we did where you go in descending order, so it's going to drop from left to right. Just a regular bar graph, but in addition to that, circle graphs are categorical, and also time graphs are categorical. Again, it's because the bottom or typically when you do a graph, you have an independent variable and then a dependent variable on the side. Variable and variable. And those are what make up the axes for your graph. Other than in a circle graph, again, that one looks a little bit different. But the independent variable is based on categories. And then the dependent variable is a number that represents that particular situation. Okay. Sometimes the categories look like numbers, like in the graph that's here, it'll be, 5, 10, 15, 20. But that is the category of wind speed. When the wind speed is calm or not at all, we're at 50 degrees. When the wind speed is 5 degrees, it makes it feel like 48 degrees. When the wind speed is 10 degrees, it makes it feel like 40 degrees. So that's our categories are the wind speed, and then our value that is represented by each category would be the equivalent temperature. Okay. Not that that stuff is all that super important, but just to kind of explain what the types of graphs that we're going to be working with. So when you make a bar graph, there is a sort of checklist that you go through, make your table and organize the data. Most of the time you'll be given that information. Every once in a while you'll have to fill one in, like the ones you did in class yesterday, you'll fill in. And then decide your scale. The scale on the side is sometimes a little bit tricky to figure out when you set it up. So just sort of look at the lowest to highest values. So my lowest value, it turned out that this one was in order from highest to lowest. So my highest value is 50, my lowest value is 30. So I'm probably going to start my graph at 30 and then end it at 50, and maybe I'll count by 5s or 10s or whatever. So it just depends on the layout of the graph that I'm given. If I don't start at 0, which I'm planning on doing here, I have to use a squiggly line to represent that on my graph, and I'll show you that once we put that all together. Then make your bars, label your axes. You have to make your bars uniform and make sure they don't touch. A different kind of graph has touching bars, and we'll get into that tomorrow and the next day. Label your axes, make sure that you have a title on your graph. Okay. So again, I took that information and I already sort of put it into my graph. I'll raise this up a little bit. You can pause and catch up, or you don't even have to get the picture down if you don't want to. That part kind of doesn't matter. It's really more important that you go through the parts and what type of graph it is and have that information in. So because my lowest is 30 and my highest is 50, and 30 is not at 0, we put this little squiggly in here that shows everybody that I did not start this at 0. So you don't always have to start at 0. We talked a little bit about that bottom line being 0. If it's not going to fit the graph data too well. This isn't always the best way to do something, because it really takes away the differences in the heights of the bars. If you do a little squiggle and spread these values out, it makes things look further apart than they really are. But it definitely is a way to shorten up the amount of data that you have to put on, especially if they're very far apart from each other. So this little squiggly, if you don't start at 0, you're going to want to put that in. And then decide how you're going to number it. That part doesn't matter that much either. And I'm not sure why I chose this, but it just seemed to work. So I did 30, and then each line was 2. So 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. And the reason that I wanted to put that in there is just to show also, don't feel like you have to number every line. You can use lines that are represented by different numbers and count off differently. You don't always have to count by 1. Just do something that's going to fit in the graph nicely. Sometimes that's going to take some playing around. Again, don't forget to label your sides, and then make obviously your bars. These two colors were sort of similar, so if you're running out of colors and you have so much information, feel free to make one that's decorative or has sort of a pattern as opposed to a solid color. You can do things like that, but typically when you're doing them, you want to make them all stand out as a different color or different look to them, so that you can tell they represent a different category. And then the last thing that you always want to do is include your graph. And what's nice about that is most of the time they'll tell you what your title is, because they'll say the table show or make a graph that shows. And so this is the wind chill at 50 degrees. And so that's what I'm just going to call my graph, wind chill at 50 degrees. Okay, so that's a standard bar graph. Independent variable, dependent variable goes on the side. These are all my categories along the bottom, and then the values that represent them. Then we get into that Pareto or Pareto, again, that type of graph. You also did one of those in class. And that one is, again, descending order. Oops, I don't know if you can see that. It gets kind of bright there as I move. Descending order means your bars are going to drop from highest to lowest. And again, they're going to tell you the table shows the causes of lateness for class. That's how I got my title, Lateness for Class. So I look at my data and try to figure out how I'm going to number it when I'm making my graph. This one's not in order from highest to lowest, so I'm going to have to, when I write down my independent variable along the bottom, I'm going to have to make sure that I put that in order, like last minute study will be my first one, then snoozing after alarm goes off will be my second one. So I went ahead and did all that. And then I, again, figured out the side. I knew this went from 3 to 20, and I wanted to make it tall enough. I don't want to make it too scrunchy. You know, in the last one, I didn't really use all of the information here, but I did try to make it spread out a little bit. I'm not always going to make it go to the exact top. You just sort of have to play around with it. It just turned out that this one I could go by twos. It would be 0, 1, 2. I just did every other one, and that was able to get me up to 20. So once I have that all set up, I can make my bar any width I want. I just have to make sure that I make them all the same width. So the last minute studying bar, I will make that go all the way up to 20. I know you get the gist of this. Make it the same width as all the bars, and also make sure that you go the same distance between. And so the next one is the 15. So I'll get up to 15. I'm deciding that I'm putting 2 in between. I kind of chose to do these thin like this because it was easy for me to color that in sort of quickly, as opposed to making it fat and wide. And if you have time, sometimes if I have time to do it, I'll make them a little bigger or a little fancier. But my next one then is 13, so I go to 13. I skipped 2 things and went to 13. I know you kind of mentioned yesterday you're sort of like me, things sort of need to be careful or perfect, and you measure them out with a ruler or whatever. And so if I'm doing this on my own, I do spend a little bit more time making sure that it's clean and neat and follows a solid line. But if I'm just doing it for, again, just kind of to quickly show what's going on, then I'm maybe doing this a little quicker than I normally would. But my next one has a height of 9. I'll go up to 9. And my last one has a height of 8, so I will go up to 8 on that one. I'm just trying to find a color that I haven't used yet, but I think you, again, get the gist. So my 8 would be similar in color, a little bit brighter. I think that there's enough difference. If I'm not sure that it's enough difference, sometimes, like I said, I'll make it stand out by just putting a little pattern on it. So put little stripes on that yellow one instead if I run out of the colors. But bar graphs, you did a great job on those yesterday, so I think you get the gist. Again, the big thing here is making sure that they don't connect, making sure that you put all your labels on and know what your title is. Do enough spread if you can. If it doesn't start at 0 and it doesn't make sense, know that you make a little squiggly. Up next we have a time plot and circle graph. And time plots are pretty easy, I think. They're kind of like plotting points, but they're just little dots. And so when you do a time plot, it's another categorical. My categories are the weeks here. And I have week 1, week 2, week 3. I know these are numbers, and we're going to talk about numerical graphs, but because the number represents week 1, week 2, week 3, we call those categories. And then up the side, again, I have to look for the lowest to the smallest, and it's in the 1 points, and it goes up to, looks like the highest is 2.7, so I decided I'm going to go 1, 2, 3 here. Not necessarily maybe what everybody would do. It's just, it seemed to make sense for me. And again, keep that in mind when you play around with that. You can put it any way that you want to put it. There's no exact one right way or one wrong way. Just make sure you try and spread out the data enough. You don't want to get too scrunchy. Like I don't want to go 1, 2, 3 right here at the bottom and only make my plot super short. I want to be able to spread it out so that I can see some movement on the graph. And if I don't start at 0 again, I put a little zigzag in there. But I'm starting this one at 0, and I'm counting as 0.2, 0.4, 0.6, 0.8, 1, 0.2, 0.4, 0.6, 0.8, 2, 2.2, 2.4, 2.6, 0.8, 2.8, 3. And so when I make my points, I go week 1 is 1.5, and so I put a little point at 1.5. Week 2 is 1.4, so I put a little point at 1.4. Week 3, 1.7, I approximate where that is, and keep putting those values in. So then I continue and make my dots. So 6 is at 2, 7 is at 1.9, and I'll just start to see this is sort of like a scatter plot. Things will be moving up and down and bouncing back and forth, but I just continue to make my lines. I'm just looking up here and following along. I'm on week 11. 2.1 is in between. 12 is 2.1, just dots. 13 is 2.3, 14 is 2.3, 15 is 2.2, 2.4, 2.5, 2.6, back down to 2.4, and then lastly we're up at 2.7. So I filled in all my dots, and what you're going to see is patterns over time, hopefully, or that's what our goal is. We look for, are things increasing over time? Are things decreasing over time? And that's why we call it a time plot. Or is there no relationship over time? Is this time that I'm spending and tracking this, is there no correlation? And so what we look for in statistics a lot of times when we're looking at the plots is what's happening. And so if you see in a time plot that over time, this is the distance covered for a 30-minute jog, that this person who's jogging over these weeks has increased the distance that they're going, they're building their endurance, and of course that would kind of make sense that there's what we call a positive relationship. The thing with the side that we do when we number these things that we look at, that's why it's kind of careful to pick nice ones, but you don't have to overthink it too much. If I were to spread this out more, I would see a more positive relationship, like it would appear to be a more positive relationship because I would be spreading those numbers out more. And again, those are the things that we kind of look at in statistics. So the last one we did was the circle graph. And the circle graph is the last categorical one I think that we're going to talk about, and then we're going to get into the more numerical. But the category, or the circle graph, is the one that's real different because it's not, you don't have your independent and dependent variables. What you're doing is just displaying values by percents. And so keep in mind that when you're making your circle graph, you want to work with the percents. So you're either going to be given a percent or you have to find a percent. But most of the ones you'll see will be given a percent. We'll talk about how to find a percent when we do some of our other graphs as well. And we just take that percent and divide it by 100 to get our decimal. And we do the decimal percent of 360 because the whole amount around a circle is 360 degrees. And then I kind of round these off. I could make this one 73 and 50 and 58 and 79. The whole goal is to get about 360 degrees when you're done. You don't have to worry too much about it. As far as the rounding goes, just get kind of closies and get your end result to be, like I said, about 360 degrees total. And then you're going to take your protractor, and remember, half the circle is 180 degrees. So usually I start by kind of drawing, for me, a line down the middle, a pencil line that gives me about 180 degrees that I can work off of. And then this is 172.8, so I'll go and line that protractor up around the center. And then again, this black line here is what I'm lining up along my straight top line. It's kind of bright and hard to see, but you can kind of see that black line there, lining up along there. And then I'm going to go out to 172 degrees. It's off the graph a little bit here, but I'll make my mark and then connect it at 172 degrees and create that. Then my next line goes off of that line. So I'm going to line up, again, the center circle at the center of the graph, and then this black line will go around, line up with that new line that I made to get my next one. That one's about 50 degrees. The thing that you have to look at is, on your protractor, you know, you have two numbers that you're starting with, 10 and 170, 20 and 160. So wherever you're starting, I'm coming down here, I'm going to start this counting at 0. So I'm going to be using this outer one when I measure my 50 degrees. So I go in there and measure my 50 degrees, make my mark, and then again draw my line down to connect it to the center. I'll do the next one, 57. That starts off of here. 57 degrees. These are, now you can kind of see my numbers again. I'm starting at 0, so I'm going up to 57. I had to make that over here a little bit just so I can connect it. It's off the paper, but I'll go back down and connect that to my graph, my circle graph, And then that one was pears, and they are 16%. And the last one that's left is the oranges. It should be about it should be about 79 degrees. So if you want to check it just to make sure you did all right, that last one should be again up here, and it's about exactly what I wanted it to be, about 79 degrees. Brings me back to the beginning. And that's your goal when you do it. That's why you have to kind of watch these and make sure they get to 360. But when you're done, do your coloring, fill it in. You just highlight it just to save from coloring. That's great. So my apples are that color. If you want to make it really pretty, color the whole thing in. Sometimes, like I was talking to you yesterday, they do a little key on the side. We'll talk more about that in some of the other graphs that we work with as we work through our numerical graphs, as well as a little more practice with these categorical graphs. But my last thing that I have to do is put my title on. The table shows the different types of fruit trees in Mr. Reed's orchard, so I'll call this fruit trees in Mr. Reed's orchard. So get these, again, notes down if you need to look up some words or things like that. You have the book. A lot of these things come right out of the book, so you can check that if you want to. Otherwise, we'll try and cover everything that we do in notes or in class. What I'd say would be good for you to practice on today is problems 3, 5, and 6. At least try number 6, because that one is a time graph, so that you can give that one a try, because you haven't done a time graph at all yet. So if you're running short on time, then you can use that on your homework, that time graph. On problem number 6, the time is the date. So where we had week 1, week 2, week 3, you're going to have 1986, 1987, 1988. Even when you do this on the bottom of your graph, you don't have to number them all on there. You know, I could start with maybe this is at 1985, and then 86, 87, 88, 89, 90, 1990, and so you could break it up like that until you get to the 2000s that you want. It might even make more sense to spread it even further than that, but play around with it and see what gives you a good separation in your graph. And then I look forward to seeing you again tomorrow, so I hope you have a great day. We'll talk soon.